Hey guys, welcome back. So today we're going to be looking at how we convert fractions to decimal and how we convert a decimal back to a fraction. So we're going to go ahead and do an example for conversion of fractions to decimal and then converting decimal back to a fraction. Let's go ahead and get this done. So say for example, we're trying to convert this fraction to a decimal and we had 8.5 and we were trying to convert 8.5 to a decimal. In this example, we have a whole number component and we have a fraction component. Since we have the whole number component, we're only trying to convert the fraction component to a decimal. So here we have 1 over 2. And of course, some of you might know that 1 over 2 is equal to 0.5, but how did you get 0.5? Let's go ahead and do the division so that we can explain how we arrived at 8.5, because this would have just been 8.5 as our final answer. But how did we get that 8.5? So if we have 1 over 2, it means that we're dividing 1 by 2, and we're just going to go ahead and use long division for that. So we're dividing 1 by 2. So of course we have 2 into 1, or 1 divided by 2. We know that we cannot get 2 in 1. So we're going to have to follow the steps or the procedures for long division. In this case, we're going to go ahead and add a decimal point and then add a 0. So of course here we have 2 into 10, or 10 divided by 2, that gives us 5, and 5 times 2, that gives us 10. So now since we have no remainder, we know that 1 divided by 2, or 1 over 2 is equal to 0.5, and that is why we got 8.5 as our fraction converted to a decimal. Let's go ahead and do another example. Say for example we had, and that's our second example, 5 over 8, and we were trying to convert 5 over 8 to again a decimal. So we're still following the same procedure. We're trying to do long division again, so we're going to go ahead and do 5 divided by 8, and do not confuse this with 8 divided by 5, because I know a lot of times when students are trying to convert 5 over 8 to a decimal, sometimes they might make an error, and instead of doing 5 divided by 8, they have 8 divided by 5, and of course that would be incorrect. So make sure that every time you do this, you're doing the correct thing. You have 5 divided by 8, so this is 5 divided by 8. So now again, we're going to do the same thing like we did here. How many times can I get 8 in 5? We know that we cannot get 8 in 5. So because we cannot get 8 in 5, we know that our answer is going to be a decimal. So we're going to go ahead and add a decimal point here and add a 0. So now we have 50. How many times can I get 8 in 50? So we try to do our times table. So 8 times 6 gives us 48. So we know that we can get 8 in 50 6 times. So we have a 6 here, and then we're multiplying 6 times 8 gives us 48. So 50 minus 48, that leaves us with 2. So again, we do the same thing. Since we have no number to add, we know that 0 will be our placeholder. So we have we have 8 into 20, that's 2. So of course 8 times 2 is 16, and 20 minus 16, we have 4. So again, since we still have a remainder, we're going to have to try to not get a remainder. So again, we're adding another 0. And how many times can we get 8 in 40? That's 5. And now we're all even, because 5 times 8 gives us 40. So now, since there is no remainder, we know that 5 over 8 as a decimal is 0.625, or we can just simply say 0.625. With decimal now back to a fraction. So say for example, we had this decimal 8.52, and we're told that we need to convert 8.52 back to a fraction. How would we do this? So again, we have 8.52. 8 is our whole number, and 0.52 or 0.52 is going to be the decimal component, and we're trying to convert that decimal to a fraction because we already know that this is going to be the whole number component when we rewrite the fraction. So we can ignore this for now, or we can just go ahead and put it to the side. So we know that 8 is our whole number and 0.52 is going to be the fraction component. So here we have 0.52. If you notice, we have 2 decimal places. Typically, whenever we have 2 decimal places, it means that we have a number in the 10th position and a number in the 100th position. So since we have a number in the 100th position, we're now going to go ahead and make 100 our denominator. So now we will have 8 and 52 over 100. And again, the reason why we have 100 is because the number farthest away from the decimal is in the 100th position. So we have to put whatever the decimal portion is over 100. Say, for example, if we had that number, it was, say, 8.567. Here you notice, instead of having 2 numbers in front of the decimal point, we have 1, 2, 3. So in this case, we have a number in the 10th position, the 100th position, and the 1000th position. So in this case, 1,000 would be our denominator. So we would end up with 8 and 567 over 1,000. So this is just a side note, so I'm going to go ahead and erase it. Alright, so we have 8 and 52 over 100. But by looking at this fraction, you will notice that 52 and 100, they do have a factor in common. 2 is the HCF of 52 and 100, which means that we can go ahead and further simplify 52 over 100. So if we divide 52 by 2, you can take that in steps for those who can't do it in just one simple step. So if we have 5 divided by 2, that would be 2, and we're left with 1. And then, of course, 12 divided by 2 gives us 6, and 100 divided by 2 would be 50. Or we could also look at 100 here. 10 divided by 2 would be 5. And then, of course, we have a 0, so we just put the 0 right there. So if you notice again, we have 26 over 50. It can be further simplified. We're going to go ahead and divide both numbers by 2. So 26 divided by 2 gives us 13. And 50 divided by 2 gives us 25. So the HCF was actually 4 and not 2. So now we are left with 8, which is our whole number component. And then, of course, a fraction in this case is 13 over 25. So the final answer would be 8 and 13 over 25. Let's do one last example, and then we'll wrap things up. So say, for example, we had 3 and 3.9. And we wanted to convert 3.9 back to a fraction. So again, 3 is our whole number. We have points, and then, of course, we have 9. So here we have 3.9. So remember, again, we're looking for the number that's behind the decimal point. In this case, we have 9. That's behind the decimal point. 9 is in the 10th position. So we're going to go ahead and put 3 and 9 over 10, because 10 will be the denominator, because, again, the 9 is in the 10th position, and it is the only number that is behind our decimal point. So we have 3 and 9 over 10. Since 9 over 10 cannot be further simplified, our final answer is 3 and 9 over 10. I really hope this was helpful, and please stay tuned for more exciting information, and please do not forget to subscribe to my channel.